Welcome back. Next up, we're going to switch gears to talk about a completely different OpenAI model, which is DALL-E, specifically DALL-E 2. Now, you're likely familiar with DALL-E. It's been very popular. It sort of became the news sensation of the year before ChatGPT was released. It is a image generating model. So it takes in text, a prompt, and it will generate images based on that text. So I'm not going to talk much about how it actually works behind the scenes, but basically it was trained on tons and tons of images that were labeled with text descriptions. And now it usually will give us decent enough output, although sometimes I'm not thrilled with the results. If you give it the right prompt, it can do pretty well. We'll also take a look at a completely different, unrelated to OpenAI model called Stable Diffusion in the next section that is essentially an open source competitor to DALL-E that I feel does a better job than DALL-E 2. So just like with the chat API, there's a client in the browser where you can interact with the chat, but there's also the API that you use in your code. Same deal here with DALL-E. We can try DALL-E in the browser. A lot of you have probably done this before. It's fun just to have it surprise us with some sort of prompt. How about a macro 35mm photograph of two mice in Hawaii wearing tiny swimsuits and carrying tiny surfboards, digital art? I'll generate this. It takes a moment, and then it's going to give me a couple candidate images that I can then choose from and see if I like any of them. And there we go. So we get 4 different images. And what you'll notice is sometimes things get cut off. It happens all the time. And it's more annoying when it happens when you're using the API. It does happen. It's something you kind of have to train your prompt on and maybe say, well, I shouldn't use the word train. It's something you need to refine in your prompt, where you might say, centered in the photo, for example, or make sure the heads don't get cut off. So it's generating these 4 images from that prompt. Let's try another one. A stained glass window depicting a hamburger and French fries. So we'll use it in the browser for fun, but most of what I'm going to show you in this section is how to use the DALL-E API using the OpenAI client. Basically, we'll make requests in the same way that we've made requests using OpenAI.chatCompletion.create. We'll do OpenAI.image.create. And there's some different parameters and rules that we have to understand about how it works, but that's essentially what we're going to focus on in this section. Then we'll talk about Stable Diffusion, an open source and kind of better model that does the same thing. It takes text and generates images. And then we're going to build, or at least I'm going to show you a finished project, a choose your own adventure application that allows you to sort of play an interactive story that generates images and text, and you pick a branching pathway to go down. And we'll do that using DALL-E and Stable Diffusion. You can swap them out and decide which you prefer. All right, so I'll leave you with one more. What should we do last? Abstract pencil and watercolor art of a lonely robot holding a balloon. And there we are. Very, it's got a good job of making the robot look sad and lonely. Very good one here, except they're all getting cut off, or almost all of them are kind of tight and, not enough space. The composition's not ideal, so you can tweak that. Okay, so that's the DALL-E web client where you can try it in the browser. We're going to focus on the API, and that is coming next. I'll see you in the next video. Okay, so next, instead of using the web client to generate images with DALL-E, let's do it using the API. So I'll be using the OpenAI package again for Python, although you could just send a request to the designated endpoint and that will work, but we're using the package. Why not stick with it? It makes it much, much easier. So it's as simple as openai.image.create, and then we specify a prompt. And then we'll talk about size in just a moment. So I have a new notebook where I've imported OpenAI and added my API key in. Now let's try an OpenAI.image.create. So just like we would do completion or chat completion, same deal here. It's image. And then we specify our prompt. And the more detailed the prompt, the better. Not just about the contents of the image, but also the style of the image, the perspective, the colors. There's all sorts of stuff there. Why don't I try just stealing a prompt from the actual client here? Let's see what this looks like. So far, the server has been sort of acting up for me today when I try and use the web app, but it has been working when I've been making API requests. So, it seems like it's working here. So let's just steal one of the prompts from the DALL-E website. An astronaut lounging in a tropical resort in space, pixel art. Okay. And then the next thing I need to do is specify a size. I think it will work if we don't specify a size, but we'll talk about why you probably want to specify a size. Let's save this to a variable. And let's just look at that response. Now these can take a little long because it's just more involved and time consuming to actually generate an image. But here we are, we get a response, and this response looks different than the other responses we've seen so far for the completions and chat completions. The format's different. Inside of data, we have, in this case, a list, and that list has one element that has a URL. So we can control how it sends the image back to us, but by default, it will send us a URL. So if I just copy this URL and open it up in a browser window, there's my image. An astronaut in a space resort in the style of pixel art, or something like that is what we specified. Now, this URL is ephemeral. They've changed how long it will last, but basically it's a very short period of time. If you came back to this later today, this URL will not work. Or if I came back to this, if you tried to type this URL out yourself, it's not going to work. They don't just infinitely forever store every image that they've ever generated using DALL-E. But that doesn't mean that we can't save the image. It just requires a couple extra steps, which I'll show in the next video. But before we do that, let's just narrow down our results. So let's do res of data 0. Remember, it is a list. And then I'll get the URL out of there. So let's try this again. And we should get a different image. Okay, so there's the URL. And by the way, notice it's only generating a single image for us so far. Just one at a time. But we can change that. There is a parameter, which is n, that specifies how many images it should generate. But I'll hold off on doing that until we talk about pricing. The next thing I want to talk about, though, is size. So we have 3 different sizes that we can generate. All are squares. Only square images. We can do a 256 by 256, 512 by 512, or 1024 by 1024. Now, the smaller images are faster to generate, especially if you're generating multiple, and they're also cheaper. As of today, March 27, 2023, pricing looks like this. The cheapest image to generate is the smallest at 256 by 256, $0.016 per image, up to $0.02, aka 2 cents per image for a 1024 by 1024 resolution. So I'll show generating a larger one here. The way that we specify the size looks like this. Size, and then as a string, 1024 by 1024. And let's do a different type. Instead of pixel art, let's do digital art. And we wait. And usually you have to wait a bit longer for the larger images. Again, it just gives us a URL that is ephemeral. I open it up, and it might be hard for you to tell that this is a bigger resolution, but it is. This is 1024 by 1024, and this cost me 2 cents compared to whatever it was, 0.016 cents or something like that for the smaller ones, right? 1.5 cents basically versus 2 cents. So it's not a huge price difference, but it is a difference. And then if I want to generate multiple, I specify n. So n is an integer. I don't know what the upper limit is. If we go to the documentation, I'm sure we can find out. If we go to images, this is what I was talking about. You could just send your post request to this endpoint yourself, but it's way easier using the client. It must be between 1 and 10. So 10 is the maximum that we can generate at once. Now, it can be useful to generate multiple because my experience is that the quality varies. And if you're limiting yourself to one, well, you don't have much choice. It might be good, but it might not be the best image ever. So I think there's a reason that the web client gives you 4. I think 4 is a good starting point. Where like this one is completely cut off. This one's kind of cut off too. Same thing here. This one, neither of these are amazing, to be blunt, as far as the composition. So it takes a lot of tweaking. If you're using the web app, it's easier to figure out what works, because I would probably then add something to this prompt about I want these mice to be centered in the frame and fully in the frame. And, there's things that you could add to the language to try and improve it. But when we're working with just a single shot, n is 1, well, we don't have much choice there. So let's try maybe n is 5. And then instead of res.data of 0, let's just look at res.data, and I guess we'll go with the same prompt again. So this is going to generate me 5 images that are 2 cents each. And we get a list back, right, inside of this data property that has 5 URLs. Now I won't open all of them. Let's just take a look at 1 or 2. Oh, it's kind of cool. Not sure what's going on with this green stuff, but let's try one more. All right, I like that one. So that's a start. That's pretty much all there is to the API, except for one other parameter I'm going to show you in a bit in a separate video. The next thing I want to cover is how do we actually save these images dynamically, because as I mentioned, these URLs won't last long. Now, they usually last more than a minute or two, but like I said, they've changed the window. According to the docs, they expire after an hour. So not something that you can really count on to be there for very long. In the next video, I'll show you how we can save images. But just to summarize, using the Python client, it's openai.image.create. You provide a prompt. We don't specify a model, by the way. And then a size, although you don't have to specify the size. And then n is also optional. It defaults to 1. It can be up to 10. It's just how many images you want generated. So that is the DALL-E API at its simplest. Next, I'll talk about how to save images from these URLs. Okay, so the next thing we'll do is save the images that we get back from our request. I'm going to show you one way of doing that, and I'll also show you a second way in the next video. So as we saw, by default, when I make a request, let's just go back to n equals 1, or we can even leave n off. We're going to get back some data with a URL, right? And this URL is only going to last for about an hour. So what we can do to save the image locally is then basically send a second request to this URL, just using Python. We'll get the data from this and save it to a file, and then we can view or open that image file later. So to do that, I'm going to make a directory where I'm going to store all of my stuff, so my images. So let me make some new cells here. And there's a bunch of ways of doing this. I'm going to do it very clearly labeled. So image directory, name, and I'll call it images. So this is just a variable. But then I'm actually going to make a directory, and I'm going to use the OS library here. So import OS, which allows me to do things like access the current directory, for example. So curdir, or current directory, curdir. And I'm going to join it together. So this is kind of standard Python, where I can do os.path.join, os.currentDirectory, comma, and then my image directory name. So basically, I'm just making a new path using the current directory plus my image directory name up here, which is images. And this way I could do it dynamically. And so this image directory, if we just look at it, right, it's just referencing the current directory / images, which is the name of my directory that I set up here. So then what I'm going to do is make sure that exists. So if not os.path is directory using my image directory, aka if that directory doesn't exist, make it. Okay, and I guess I'll just put this all together here. This is all kind of our basic setup. So make our directory based on the current directory plus the image's name, and then check to see, does that path exist? If not, make a directory there. So I'll run this cell, and then I can actually see it just made me an empty images directory. So we don't really have to do that, but if you're writing code or a script to go get a bunch of images from the API, you probably want to programmatically make some directory to put them in. Okay, so then we have our prompt, which I moved down here. This is what's actually going to ask for the image URL, right? We're going to get a URL. Let's change the prompt a bit. How about a mermaid swimming in a coral city? Let's see if that looks interesting or not. And I'll just keep it at 1. So this is going to make my request. I'll save it to a variable called res. And from res, what I want to extract is data, but specifically 0, and then the URL, which is what we saw earlier. So hopefully we get a URL back here. And there it is. So the next thing I'm going to do is put that in some sort of variable. Let's call it image URL. Okay, so when that finishes, I'll have a URL in here that will last for an hour. And then my next step is to go and request that URL, download the contents of it, and put that in a new file. So the next step is to start really by making that file. So I'm going to make a new file path. I'll call this image file path equals os.path.join. It's basically the same thing that we just did, where I'll have our image directory that we've already made right up here. And then I'll just specify the name in here for the, well, I can do it dynamically, or I can just call this, mermaid.png, for example. Okay, so that will make me a new file path. And then I have my URL right here for the image. The next step is to go and get that image. And the way that we'll make a request is by using the requests package. So import requests. And request has a method called get. We pass it a URL. So this is the URL we got back from OpenAI. We'll make a request to that. And then specifically the stuff that I want is located in the .content property. So I'm going to save this content, let's call it image content, equals request.get of that image URL .content. So let's run this, run that. Now if we try and look at image content, there's not much to look at. There it is. Okay, so what we want to do is save that to a file. That's our next step. So I'm going to do a with, open, and then I'm going to provide this file path, image file path. Okay, WB, which means we are writing to this file in binary mode. And I'll give it a name as image file. Then I'll do image file.write, and then I'm going to write in the image content. that we just got here. So I'm opening this file at this file path, and then I'm writing into it the content that we got back from making our request to the URL. Okay, now when I run that, if we take a look in this directory, images, we now have a mermaid.png, and there it is. Not the best quality image ever from DALL-E, but it did save that image for us. So what I would probably do next here, well, another thing we could do is actually display the image for us to look at in the notebook. That's a separate thing. It's easy enough to do, but all we've done is save the image locally on our machine. If I want to display the image, there's a couple of options. The easiest option is this. From ipython.display, import image, and then, I'll do this separately just so that we don't have to import it over and over. We call image, which is what we imported, capital I image, and then provide a file name. Now in my case, the file name should be my image file path. All right, and oh, I didn't run this line first. There we go. It displays the image for us right here in the notebook. So what I'll end with here is maybe let's just write a function that will save an image given a URL, and that way we can sort of repeatedly make our images without having to run each of these cells one at a time. So I will maybe just down at the bottom here, let's delete this and let's hide that. Okay, so down here, let's make a couple more cells. Let's make a function called save image, and it will expect a URL, and that will be coming from OpenAI. And then maybe we should also provide a image name, right? Like image name when we're setting it up, maybe, or we could just do a random image name. I don't know how we want to name these images, but let's just start with this. So we'll use images still as a default directory name. That's fine. But then when we're actually making the file, we'll use image name. Okay? So then we're expecting that we're going to get this URL back and pass it in right here. So the next step is to make the image file name, or the file path, right here, right? Image name. Join that together with the image directory from up top. Then we're going to request our URL, which we're passing in here. So I need to change this. It's just called a URL. And then we need to write the data that we get back into our file. Indent this properly. And this is still called image content. Okay, that's all looking good. And then we're not rendering the image, and that's fine. And we could decide if we want to. But this should now be able to go get an image for us based on a URL, save it to an images directory, and then we'll give it a name. So let's just try one more example. Let's make a request. This time to, what sort of prompt? How about a tilt shifted image of a ski slope full of skiers. Let's just see what that looks like. And let's also shrink this down. Let's just go to a small image. Just save me a bit of money here. Save me a fraction of a cent. Okay, let's try this. So this will go get the URL, right, into this variable. And then the next step would be to call our function save image with that image URL, and then a name for the file. Let's call it skiers.png. Okay, let's hope it works. And if it does work, we won't really see anything until we go look in our images directory, skiers.png. There we are, our skiers.png file. So I guess the last improvement we could make is just to write a function called get and save image or something like that, which will just do exactly what we just did, basically. Def, we'll call it get image, and it will ask for a prompt and also a image name. And then in here, this will only get a single image. Of course, you could write a loop and do multiple images, but we'll just do a single one. We will pass through the prompt right there. We'll have it default to 512. You could obviously write an argument here and pass that in, and we'll have it default to n of 1. And then all that we'll do after we pass that prompt in is pass our data, the URL, to our save image function, but then we'll provide the image name here. So now I should be able to do get image, and I'll provide a prompt. Prompt equals, I don't know, what's another example? A sunset from a graveyard with a skeleton reading a novel. Okay, and then the second part is the image name, and we'll call this graveyard.png. And now we just have this repeatable function that hopefully will request an image from DALL-E, get it back, and then save it into our images folder. And there it is. We got the sunset, we got the skeleton reading. I don't know, I'm not getting much graveyard, but we could obviously tweak the prompt. Let's do one more example just for fun. Let's do a 3D rendering of a melting peach popsicle against a gradient background. And we'll call this popsicle.png. And go back to images. Here's popsicle. Not bad, not bad. Okay, that's pretty much it. So in this video, we saw that we can save images by requesting the URL and then saving the contents to a file. I'm actually going to show you another way of doing the same thing in the next video that involves working with JSON data directly. Welcome back. The next thing I'm going to show you will be pretty brief. There's actually a second option for how the data is sent back to us when we generate an image. By default, if we go to the API reference, it sends back a URL. As we've already seen, it's ephemeral. It lasts for, an hour or so. But there's a response format that we can specify. It defaults to URL, but we can set it to B64 JSON, which is base 64 JSON. And if we do that, it will send the data for the actual image, not as a URL, but actually as base 64 JSON. It will send the full image data to us. And then we just have to do a little bit of work on our side to actually turn it into an image that we save. So depending on your use case, it might be preferable actually just to request the data itself. That way we don't have to make 2 requests, because what we're doing so far is requesting using our prompt, give me a picture of a cat wearing a beautiful hat. And then that takes time. We get that back. Then we're making a second HTTP request to go and load based on the URL that we got back from OpenAI. So the other option, if I guess we'll write a function to do this for us. That's fine. We'll write a function called get and save image. And we'll do that. It's going to expect a prompt to be passed through. And then we'll just copy the logic right here to make our request. And so we'll pass through the prompt. We'll just keep it at 512 by 512 to start, and will be equal to 1. But the main difference is that we're going to set response underscore format to be equal to B64 underscore JSON, as they say right here on the docs. Okay, and why don't we just start by printing the response so you can see what that looks like. So let's call our get and save image function, and we'll provide a prompt like a friendly cactus sitting in a pot, digital art. Sure. And when we run this, it takes a bit of time. But as you can see, instead of getting a URL back, we're getting JSON here, base 64 JSON. It's obviously not going to make any sense to us humans, but it is data. That is the image itself as data. We can take that and save it to a file. So that's the next step. If we want to save this image, we will extract out of data B64 JSON, and it's in a list, right? So we're going to do print res of data 0, because there's only one element, n is 1. And then we're going to look for the B64 JSON. So that should give us the actual raw data, right? We can save this to a variable, image data. And then the next step is going to be to make a file and go through that whole thing we did previously up here with all this fun stuff where we have our image directory, we have the making of the image directory if it doesn't yet exist, creating the new file, and then let's just copy this part just to save ourselves a bit of time. So we'll start by getting the image, hopefully that works. And we'll keep with the images folder name, that's fine. The only thing we will need to specify here is a new name for the image. So I guess we'll do the same thing where we expect you to provide an image name, and then we'll pass that through here. So, I might call this like cactus.png. Okay, so that should make us a new image file path. Now what we have to do is take our image data, which is at the moment base 64 JSON, and we basically have to decode it. And the way we're going to do this is by using a built-in thing called base 64. So we'll just import that. And base 64 has a method called b64 decode. And then we specify, in our case, what we want to decode, which is our image data. And I'll save that to a variable called decoded image. The final thing to do is write that out to a file. And here's one way of doing that. So we'll open our image file path, which is basically what we did previously, right? It's the same sort of concept from this video, the previous video where we were working with a URL. It's the same thing. The only thing that's different this time is that we're actually writing a decoded image that's coming from this base 64 decode method but really it's the same logic. Open a file, write mode, binary, we'll call it F this time, and we'll write to that file the decoded image data. Let's run our function. Okay, and then let's try executing. Here we are, get and save image, friendly cactus sitting in a pot, digital art. The title is cactus.png, and we hold our breath. Does it work? Okay, let's go look in our images directory. Is there a cactus.png? There it is, our friendly cactus. Okay, not so sold on the actual image itself. It looks a bit odd, but it did work, right? So this is just another way of requesting the DALL-E API. The main distinction here is that it's only one request involved. And as far as I know, this is a newer option that wasn't around originally when the DALL-E API launched. So either one will work, but this I think is a little bit faster as long as you're comfortable. And remember to call the base64 decode function. And in Python, it's super easy, right? We don't have to do anything fancy. It's just a single line to get the image data out of base64, and then we can write it into a file. Let's try one more. What should we do next? Let's do a painting of a vase full of lollipops in the style of Van Gogh. And we'll call this Van Gogh.png. And we wait. In our images, here it is. Oh, looks pretty good to me. Although, still not thrilled when things get cut off like that. But it's fine. We could adapt our prompt or request more than one image, although right now our function is only set up to actually save the first image right here. We could add a loop in and save all of them. The only other thing I would say about what we've learned in this video is you don't always necessarily have to save every image that you're creating. There are apps and use cases where maybe you do want the URL, you're just going to show an image to a user briefly, and there's no reason to save it on disk just to then delete it later. But I do want to show you, and I have hopefully shown you, 2 ways of saving those images. If you do want to use them and save them for later, do something with them. Okay. The next DALL-E endpoint that we'll look at has to do with generating image variations, where we actually provide a specific image and then ask it to generate variations upon that image. So this image could be your own image, or it could be one that's already come back from DALL-E that you like and you want it to sort of riff on. There is one very important restriction, well, 2. It has to be a square PNG image. Everything in DALL-E world is square, and it has to be under 4 megabytes in size. And the way that we do this is if we're using the client, OpenAI in Python, OpenAI.image. Instead of create, it's create variation. And then we specify the image that we're trying to get a variation on. So let's try it. I'll go ahead and duplicate our saving DALL-E images notebook because that has some of the functions they probably want to keep. Okay, I'll just rename this DALL-E image variations. Keep all the imports the same, and I'll work with the URL version instead of our base64 version. And the main reason I'll do that is because it means that I don't have to save the file. If I just get the URL, I can open it and show it to you, and we can just prove that it works. So I have my get image, and then I have save image. Let's get rid of some of these cells I don't need. Okay, so down at the bottom, what I'll do is make a few cells. And the first thing we have to do is figure out what image are we going to make a variation upon. And I'll just use one of the ones that came back from DALL-E because they're already squares. They're under 4 megabytes. Let's try the popsicle one. And you can use any image, of course, but I'll do this popsicle one. So the first step is to call OpenAI dot, and then it's image.create variation. And then we have to specify the image itself, as you can see here. And I'll do that using open, and then the path to my image is /images/popsicle.png, I believe. Popsicle.png, yes. And then the next thing is the size. I'll just leave the size alone and use the default. And then I'll say I want 1 variation to start, just because if I do more, I'm going to have to write a loop to work with all of them. And that should go and get me a new image. And it should return a URL format by default. And it looks like my API key is missing. Let's try this again. I didn't run these. Amateur. Okay. Let's try running this again. Whoops, I forgot to specify that we're reading binary. Try that again. So it was complaining. I was trying to read it as with UTF-8 encoding. We wait. And we wait a bit more. And we won't see much because I'm not actually outputting anything. So let's look at our res here. Okay. So it gave me this URL. Let's open it. And there's my variation. Original and the variation. Okay, so next, why don't we try asking for more variations, like 6 variations. So that's going to return to me a list. It already returns a list, right? Under data, it's a list with only one element, but let's iterate over all of them and save them all. So to do that, right, we're going to want to work with res dot or square bracket data, but then instead of 0, I'll do a loop. And I'm going to use enumerate to loop over the results because I want access to the index. You'll see why in a moment. It basically has to do with naming the files. So I'll do for index, comma, image in enumerate. And then I already have this handy function I wrote called save image, which expects a URL and an image name. So I'm just going to call save image. And I'm going to pass through my URL, which is image square bracket URL, because this represents one image. So I'll pass through that, but we'll have 6 of them. And then I'll pass through a string. Let's do an F string here. That's just, what should we do? Popsicle. And then I'll use a dash, and then I'll put in index. So I'll have popsicle 0, popsicle 1, popsicle 2, and so on. And I need to put .png here. Let's try running it. It will take a little while, especially if we're doing 6 images. Okay, looks like it finished. Let's go to images. All right, we have popsicle 0, 1, 2, 3, 4, and 5. Let's take a look. There's our first variation, our second variation, our third, our fourth, our fifth, and our sixth. Okay, so I just want to show one more example. This time, what I'm going to do is a more common workflow where I'll request initially that it generates me 6 images on a given prompt. It doesn't have to be 6, but let's call it 6. And then I'll pick one to try and get it to go more in that direction and generate variations upon the image that I like. So I'll do openai.image.create, not create variation, but create. And then my prompt is going to be a photo of a white fur monster standing in a purple room. I'll make them small. So 512 by 512, and I'll set n to 6, I think. So we'll get 6 of them, hopefully. Save that to a variable, and I'm going to save all of these images. So for each one of them, I'll save them using the name monster-index. So this is going to go and get me 6 new images, and then we'll open them, we'll look at the one that we like the best, and then request variations on that one that we like. So let's find them. Monster, here we are, 0, 1, 2, 3, 4, 5. Ooh, not the best. Really, not the best either. Okay, that one seems like the best so far. Yeah, not a fan of this one. Okay, so what I'll do next, see if you agree with me. Yeah, I think this one's the best. I'll take this, it's monster-4, and then I'll generate variations upon that. So I'll just duplicate this, but I'm going to change what we did here. Instead of image.create, it's now image.create variation. And then I'll keep n set to 6, but I'm going to specify the image itself, which is located at /images/monster, and I already forgot, monster4.png. All right, and then I want 6 of them. And the only other thing I'll change is down here. I guess, I probably shouldn't reuse the name res, so I'll call this variation res, and then here it's variation res, and then I'll call this monster variation. Okay, let's see if that works for us. I need a comma, and I have to specify we want this as read binary. Okay, that one took a little while, but it did finish, and here's our variations: 1, 2, 3, 4, 5, and 6. So this is the original, and then this is the variations it generated. Good variations, yeah, not bad. Anyway, so you can see how that could be useful if you want to generate variations on a given image. Whether that image is generated from DALL-E or it's one of your own images, the main constraint is it has to be square and it has to be under 4 megabytes. So that's variations. Welcome back. Next, the final thing I'll show you with DALL-E is that we can have it edit existing images, so not create variations, but create edits where it tweaks a portion of an image. And the way we do this is by providing the original image and then a masked version of the original image where we have some transparent area. And it will fill in whatever we specify with our prompt in that transparent area only, and it will try and it should get it to match the existing context of that image. And the way we do this is by providing a prompt, but also the image and a mask. And those images, the image and mask have to be squares, and they should be the same size. So I've already created, if I go to my images folder, I've created the mask for the image we're going to use is the Great Wave famous woodcut. Who is that? Hokusai. And then I've added a transparent circle to this other image, which is called great wave underscore mask. So we have those two images. And I've made a new notebook, basically going to delete what we have in here. I'll import OpenAI, get the API key going. And then I'm going to start by just opening both of those images and getting them to display. So I'll just display them so we can see them. I'm going to use, there's multiple ways of getting an image to display, but I'm going to use ipython.core.display import image. And this image function will then take a image file. So I'm going to open up the first image, which is .images or ./images/greatwave.png, and I'll specify that it's a read binary, and I'll read that file. I'll save it to a variable. I'll call it wave image, and then I'll render it using just in the notebook using image, this function we imported, and we'll set the data equal to wave image. Now it's kind of big, so I think I'm going to also set its width, maybe just to be 256 or 512 or something like that. Let's do 256. Okay, so there is the original image. Then I'm going to do the same thing for the mask. So that's called great wave underscore mask. You can download this exact image if you want with the mask, and I'll call this wave image mask. And then down below, I will render that as well. And this will be wave image mask. Okay, so the final thing is to actually make the API call, which will look like this. OpenAI dot image, and then instead of create, it's create edit. And then in here, we specify the original image, which is our variable called wave image. Then we specify the mask, wave image underscore mask. Then we specify our prompt. So what do we want to put in there? I don't know. Maybe a surfer, a boat, a fish. Let's try a surfer riding a surfboard on the great wave. Let's just see if that will do it. And then after that, I'll say n is 1, that's a default. And then size, these are 1024, so I'll just keep it. I'll go as big as possible, 1024 by 1024. And that will get me my response. And then we'll render the image on the next line. Let's see if that works for us. I'll just preemptively start typing its response, and then we want data, and then we want 0, and by default, it's going to give me a URL. And that's fine. I'll just take that. There it is. And what I can actually do is just provide that to my image. So the image function can take data, which is what we did earlier, or it can actually just take a URL. So we're not saving this anywhere. I'm just having it use that URL. Okay, I don't know how we ended up with 2 surfers, but we'll try, I said a surfer, right? A single, let's try this again. Surfer riding a surfboard on the great wave. Let's try that. I mean, you can tell it worked, right? It only added it into that circle, and it sort of blended with the original image. Let's try again. Whoops. Oh, it's still going. Okay, there we go. Yeah, it's decent.